Very much. Good morning. So thanks, Nat. As she mentioned, I'm from Wollongong, and yes, I did come up on the train this morning, so I'm still a bit sweaty. So a little bit of my background. When I was most of your ages, I was studying everything under the sun. I studied some chemistry, some physics, 3-unit maths, 3-unit English, drama, legal studies, you name it, I tried it. And by the time I got to the end of high school, I had absolutely no idea what I wanted to be. So I took a year off. Shock horror. I took a year off to work myself out, and then at the end of my year, I still didn't know what I wanted to be. So, like most people who don't know what they wanted to do, I figured I'd be an accountant, and I went and I started a commerce degree. So a few subjects into my commerce degree, I was very, very, very lucky that I bumped into something that I'm absolutely passionate about and used some of those math skills that I learnt in school, which was economics. So no, I'm not technically STEM, but yes, I do know calculus in depth, unfortunately. So studied a commerce degree with an economics major, did honours in, first class honours in economics, and then went on, was awarded the university medal. So from having absolutely no idea what I wanted to do, finding something I was passionate about, and then just nailing it. And that's my biggest piece of advice to people at your age, is that take your time, let something speak to you, and when you find something that does, just go with it and go hard, and you'll be amazed what you can achieve just because you're passionate about what you're doing. But that's not why I'm here to speak today. I'm here to speak because I've started a business. That was all a very long time ago. Since then, I ended up working at KPMG as an economic consultant, which was fabulous. I learned what it's like to do cool projects, work in other countries. I worked in Sydney, Canberra, Paris, Bahrain. So I've done stuff all over the world with them. Very exciting, very, 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 very exhausting. And after having learnt all of that great stuff, I came back to Wollongong to start my family, and I got a great job with BlueScope down there. So in BlueScope I was doing forecasting, again, got to do all my business analysis stuff. But what was really, really cool is that I picked up a whole bunch of stuff about business, about strategy, about product, about marketing, about operations, supply chain, all this amazing stuff, and a lot of how it can be done well, and a lot of how maybe not to do it so well. So when I was 30, when I was 30, myself, my husband, who's a product designer and mechanical engineer, and one of our friends from university. So I was on the FSAE race team. I don't know if you've heard of that, any of the undergrads. Your uni does really well in it. My uni used to do really well in it. So I was on the FSAE team, so I pretty much knew everyone who is in the engineering faculty, and that's how we picked up our third co-founder. And between the three of us, we put together a 3D printing business. So what's really interesting is that, as Kate mentioned, there's those big 5 dot points that you need to cover off if you want to be an engineer, if you want to be an entrepreneur, if you want to start your own business. The first one being product. Now, I learnt a lot about 3D printing, and I could very, very, very quickly see the marketing opportunities, the global opportunities. Oh my God, the disruptive nature of the technology is super exciting. But what I didn't have was an engineering background. And so all of that I learned, if you will, on the job as we developed the business. But what I did bring was I brought marketing, I brought operations, I brought financials, I brought pitching skills, which is what I'm now renowned for, unfortunately, and I brought risk management. So even though I didn't have that first part, I was able to find the right people. I was able to identify that we had the right skill set in our team, and we had to quickly expand to bring others in as well. And then I was able to also bring a whole bunch to the table in the forming the business around the product part of the story. So that was in 2013. I had my first son. And while I was on maternity leave, like he was 2 weeks old, we played with our very first prototype. We turned it on. And a year later, we had a product in market. So we were selling stuff that we were making in my garage. I think I still have the cuts and burns from soldering stuff at 3 o'clock in the morning, putting the product together. And I was still working at BlueScope, and I still had a baby, and we were doing all this nights and weekends, and it was very, very, very hectic and incredibly exciting. So I think, as Kate said as well, if you've got an inch of that ambition to be your own boss and do your own thing, and the inspiration to run your own show, try and jump on it as young as possible, because life only gets more complicated after that. And I know that in my own story, it was a good thing. It was a good thing that it happened to me a little bit later in life. I think while I was, I had a brain and I had a lot of ambition, I didn't have a lot of confidence. And I know that coming into it at the age I was able to say, no, I have worked in very male-dominated industries. I have pitched to the Minister of Finance in a room full of sheikhs in Bahrain and convinced them of their tax model. I have dealt with ministers out of Canberra. I have done all this cool stuff. I've been talking to the CEO of a company of 20,000 people globally. I've done all this stuff. And it was very intimidating at the time. And I came out the other side of it and I realised I have a brain, I have ambition, and I'm capable. And they were the important things that I needed to gain over my 20s. So if you can convince yourself of that now, you are way ahead of the game. So Me3D's been in operation for about 3 years. We are selling into schools. It's our primary market. So when we started with 3D printing, I mentioned I worked in Paris. It is pretty much unlivable for about 10 months of the year. So we bought a 3D printer and we played with that all through the winter. And came home and said, look, this is an incredibly powerful technology. How do we make sure this doesn't go the way of the personal computer? Where, well, when I went to primary school, I think I was in year 4 or year 5, and we had one PC in the library that everybody shared. And then by the time I left school, there was one lab of like 20 PCs for a school of 1,300 children to share. And here we are, don't want to admit how many years later, and finally everybody's using this. It's not something that you have to learn about in isolation. It's now a tool that everybody uses. And 3D printing similar, certainly when it comes to anything related to physical product design, physical supply chains, biomedical, they're using it in building and construction. We're seeing it come out as an assistive device. It's being used in all sorts of, like occupational therapies. We're seeing it expanding into people are experimenting with doing things like food production. But what I was excited about was really the disruptive nature of physical products. So the idea that if my kid stomps on my TV remote, that I don't have to order it off of Amazon and have it go through 15 different countries and expend a ton of CO2 to get to me to get a replacement, that I could use local materials and produce something for myself on site. And then the extension of that is that I could produce something that's exactly right for me on site. And instead of there being 10,000 of this standardised universal TV remote sitting in a warehouse that only a third ever get consumed, actually we only produce exactly what we're going to use, and it's exactly appropriate for the person who's using it, and it's produced locally. And that's the stuff that got me really excited. But to do that, everybody needs to know how to 3D print. And at the time, it was this big black box. Oh my God, it's so magic. It is not magic. It is child's play. It really is. It's the simplest technology, and it was developed over 30 years ago. It was just something that wasn't accessible to most people. It was something that was, hidden behind patents that, the machines were $50,000, $250,000, to have any sort of capability. So that's when we decided that actually the best way to make sure that everybody knows how to use a 3D printer so that one day we can start to change the way that we consume is if children know how to 3D print. And so that's why we went into schools. And now what we focus on is kids as young as 6 and 7. So we started off with a device that we designed for the classroom. It's nice and open, everyone can see what's going on, it's really safe, there's no hot moving parts, the teachers don't need to worry about it being a hazard. And then we realised software. Software was our next big problem. All the software that was out there was all dashboards and jargon and complication. It was too many choices. And even though kids were quite confident to come to it, the people that were teaching them and the people that owned the property and were concerned about it being damaged were very not confident about it. They thought it was too complicated. And so we redesigned the software. We've got our own software now. One of its kind. It's the only, you basically have Google, Apple, maybe Microsoft, and Me3D in terms of connectivity to the New South Wales Department of Education. You plug it in, open up a browser, and now you can operate it. And it is a simple, basic workflow. It takes all of the stress of all that complexity out of it, and it focuses on the lesson, on what are we learning about the process. And then the other thing that we've done is now we've got a platform of education content. And what we try to do in our education content is we use the device not just to produce stuff, but to learn about how you're producing stuff along the way. So we have lessons around the thermal properties of the plastics that we use. Our core product is polylactic acid, which is a biodegradable material. It's the same thing your coffee cup lids are made out of. But there's variants on the PLA that make it stronger, make it flexible, make it dissolve in alcohol. So there's lots of things that we can do just by looking at variations of the plastics that we're using. We use the robot itself to do coding apps. So you can code up parameters to make, for example, there's a project, we don't do this, it's way more complicated than what we do, but there's a project out there for people who've designed prosthetic limbs, except you can imagine that, and I'm sure everybody's heard about how exciting prosthetic limbs are from 3D printing. It's something that would have been $20,000 every time you needed a replacement prosthetic. For a child, that would be every 6 months because they're growing so rapidly. With 3D printing, now it costs like $2 of plastic. So we can give multiple prosthetics to one patient. We can be updating them and replacing them constantly, and they can be way more capable than anything that we would have done when we were moulding plasticine and welding or whatever they used to do. But the project is to take prosthetics and there's a program that's been written around it, and then to parameterise those prosthetics. So this child has an arm that's this length, their radius is this long, the ulnar is this long, their range of motion in their elbow, etc. So there's coding-based stuff going on in 3D printing everywhere. Obviously, it lends itself really nicely to be a complementary technology, doing things like robotics. You design and print your robot. You design and print the tools that your robot can interact with. What else? Oh, so much exciting stuff. I don't know where to stop. Have I used my time up yet? Still going? Okay. Where was I going with all of that? Oh, the type of education content that we do. So we also have a whole area that we're working on to build out to do mathematics. So maybe I should have had a video or a slide of what our 3D printer looks like, but has anybody not seen a 3D printer? Couple. To give you an idea, it is a robot with an X, a Y and a Z axis. And that's it. It is literally 3 motors that drive ahead in the Z, X and Y planes. And all it does is extrude hot plastic out of very fine nozzle, about the size of a hair, if you're doing it in a lot of detail, and it extrudes it into shapes on a flat surface, and then it layers on top of each of those shapes, and obviously it changes over the layers, and you can produce just about any form with that technology. That's the core technology. It's called fused deposition modelling. There's other types of 3D printing as well, which is super exciting, but at its core, that's pretty much still what they do. They layer materials, and they do it with geometry. That's it. That's all it is. So we do maths lessons where we print out parabolas and complex 3D planes and things like that. So you can actually, I don't know about you guys, but I remember when I was learning about minima and maxima and turning points and stuff, and I was like, I wish this would just be a little bit more intuitive. I wish it would stick better. And that's exactly what we're trying to do. See the valley in this thing that you're holding in your hand? That's the minima. Anyway, we've got geography classes that we do. So we've been working with a bunch of geologists who are doing all this incredible stuff in global mapping. And we've taken data. I think my favourite one is Mount St Helens. You're all too young. Mount St Helens is this massive volcano, and it's really hard to grasp the scale of this thing, but I think it exploded in it was earlier than that. I can't remember what year, a long time ago, possibly even before I was born. It exploded, and they didn't even have 3D data of this thing because it was so long ago. So what they had was the old topographic maps, you know, on paper with the lines that tell you the step. Yeah, that's all they had of this mountain before it exploded. So they've taken that data and they've extruded that out to be fine detail map of the original mountain, and then they've done it again with the existing mountain, and you print it as two separate parts, and then you do a little exercise where you get a dish of water and you submerge the exploded component and work out how many metric tons of rock were destroyed in that explosion. And it's super fun, right? It's not like, I don't know, I'm looking at some of the people closer to my age in the room, but when I did geography, oh my God, it was so boring. It was so boring. It was lots of reading. It was very abstract. And it was not super interactive, unless you got to do cool field trips and stuff, which I think comes down to your teacher and how excited they are about geography. Yeah, so that's where we're expanding into now, and I think bringing it back to the business and where it's at today, one of the important things about what you do is about being passionate but also flexible, and I think we're in an accelerator out of Wollongong called iAccelerate now. So being in that environment, we see lots and lots and lots of businesses come through. And obviously I pitch to everyone in town, so I meet lots of other co-founders and stuff like that. And I think what you tend to see is a lot of co-founders who are the technical product person, who are very, very, very tightly held to their idea, who sometimes struggle to find how they can make that idea speak to the masses and speak to their market. Sometimes you see technical founders in particular who are reluctant to surround themselves with people who maybe can help them take that product and turn it into a marketable product, which is the sort of thing that Nat does in the commercialisation space, helping you take technology that sounds cool and make it something you can actually make money out of so you can keep making stuff that's cool. Thank you. And so, yeah, that's one of the best things about our business is that we have the three of us. And today we are in 300 schools, mostly in New South Wales, but we've got some in every state. As I said before, we've partnered with the DET and we've, not to make it sound hacky, but we've cracked their network issues, so that's super exciting. We're the only company, 3D printing company in Australia that does that. We've raised $500,000 in investment. We have a team of 10. I'm the CFO, so I get to do all the accounting, it turns out, in the end, after all of that. And we're kicking goals, and it's going really well. Is that okay?